All right, Bernoulli trials. There are two possible outcomes. What are they?
Success and failure.
Success and
Wait, is that right?
failure.
Yep. Success, which is P. Failure, which is Q. And remember, Q is 1 minus P. The probability of success always stays the same. And trials are independent. And if not, they've got to meet that 10% condition. Don't forget. All right, examples of Bernoulli trials. Anyone got any?
Like logging into a computer. Success, failure.
Answering true or false questions on a
Oh.
test.
So logging into something, yeah, that would work. True or false questions on a test, yeah, that would work.
You want us to write these down?
You
Entering
can.
your,
I'm gonna write a few in a
social
minute.
security
Just
number on, like, legal documents. Like,
what?
to, like, get it right or wrong.
I'm thinking things like flipping a coin. I can get heads or tails. One's a success, one's a failure.
What about,
I used to rush them.
like, flip. What else can you flip?
How about free throws in basketball?
Yes.
I mean, you could flip yourself, you know? I don't know. Trying to show off or something?
Could flip a burger.
What?
Flip a burger.
Oh, I think you said flip a bird, and I was like,
Oh.
I was like, not in here.
That would never
What about like a
Catching a ball?
what's it called?
penalty kicks in soccer.
That's exactly what I was thinking. Thank you, Nathan.
That's definitely what you were thinking of.
No, it actually was.
Serving,
Yes.
tennis.
Yes.
What's another one you have?
Another one I have.
Getting
Looking for a defective product on an assembly line.
Pardon?
What'd you say?
Looking for a defective product on an assembly line.
So it's like
Can you explain
It's
that?
either good or it's defective.
Right.
Like the emails. It's either a good email or it's a spam email.
Right. Okay.
No way.
So a lot of those things, like most everything y'all said is fine. So you can write out whatever you're feeling.
Depict the
Where's paint?
Bathroom. Geometric model. It's modeling the number of Bernoulli trials.
Is this the same Bernoulli from physics class?
I have no idea.
Didn't you guys ask that when we were going over the notes the first time?
We did, and we didn't look it up. No, we asked it instead.
Yeah, because I was here for that.
Part of my assumption would say yes, because that's like not a common name, but I don't know. Maybe they're like cousins.
Maybe they're like brothers who like went to two different maths.
Physics and stats.
Maybe it's like, maybe it's the same guy and he was trying to figure out the statistical probability of the physics working.
Sure.
Cheat sheet reason.
10% condition. I have no idea what you said. In geometric models, trials aren't independent. Since we are sampling without replacement. As long as our sample is less than 10% of the population, we can assume they are essentially independent. Suppose a computer manufacturer rejects 2% of the chips produced because they fail pre-sale testing. What's the probability that the 5th chip is the first bad one you find? So, the probability of bad is equal to 0.02, okay, because 2% are rejects because they fail. Now, looking at our conditions, okay, the trials aren't independent. But 5 chips is less than 10% of all chips manufactured. So mathematically, we would say P of x equal to 5 is equal to the success. So the first 4 are good, would be 0.98 raised to the 4th, times the 5th one is the first bad one, so 0.02. Let's see what that equals. All right, now I can also do this with my calculator with geometric PDF of 0.02. So that's the first bad one being the 5th one, so 0.02 and then 5. Okay, so P is success, but it's like when we in the formula we usually say P then N, but it's whatever we're looking for. So we're looking for the first bad one is the 5th one. So that's why it's 0.02 and then 5. So remember that's under second VAR's distribution. I don't have my calculator in front of me, so I had to think about what it said. What is that? Look at us go. All right. On the flip side, what is the probability that you find a bad one within the first 10 that you examine? So this is going to be the probability of 1 less than or equal to x less than or equal to 10. So that means that somewhere in the range of the first 10, I'm going to find a bad one. So, I'm going to write this out, but we're not going to math it that way. We're going to use the calculator. But I want you to see what this would look like if we did this. This would be, let's say the first one was a failure. So it would be 0.02, okay, raised to the first, but we're not going to write that. Plus, the first one's good, second one's bad, so 0.98 raised to the 1. 0.02 raised to the 1, that would mean that the second one was bad. Plus, first two were good, third one was bad, so 0.98 squared times 0.02 to the 1. Plus, all the way out to the last option of the first 9 were good, the 10th one was bad. 0.98 raised to the 9th times 0.02 raised to the 1. Okay, now you obviously wouldn't have to write the ones, but I'm trying to just get you to see it visually. Okay, so there's obviously a bunch of terms in the middle that we're missing. But you probably, my guess is, don't want to have to do all that math by hand. So we can instead use geometric CDF, okay, because that's the one where we're adding them up. Or seeing like how many are in the first amount. So 0.02 and 10.
I got 0.18.
183. Now, the other option is we could have also done 1 minus the probability that there are no bad, bad, in the first 10. And that would have been the other way we could have done it, but the way I did it is probably the easiest way. All right. We don't have a lot of time, so we're not going to start the next one because it's a whole page problem. We probably won't finish tomorrow, but we should be able to get through a decent amount of them and wrap them up on Wednesday. And my plan is to do a quiz on Friday on chapter 16 and 17
Okay.
together.